Welcome to Brain Vision.
Question number 83 is somewhat similar to question number 79 in that it is a two-equation, two-unknown calculation. It is related to the concepts in this chapter in that we need to have a balanced chemical reaction. We're going to have two reactants. With two reactants, we need to figure out the amount of product that each reactant can create. The one that produces the least amount of product is the limiting reactant, and that amount of product is the theoretical yield. So let's start with the balanced chemical reaction. It tells us that we have aluminum metal reacting with manganese 4 oxide, producing aluminum oxide and manganese metal. When we balance it, we'll need to put a 4 in front of the aluminum, a 3 in front of the manganese 4 oxide, a 2 in front of the aluminum oxide, and a 3 in front of the manganese. Then to set up the equation, we need to define a couple variables. As I mentioned, this will be a two-equation, two-unknown calculation. What are the two unknowns? Well, we don't know the mass of aluminum that we are starting with, and we don't know the mass of manganese 4 oxide. So we'll define aluminum as X and the manganese 4 oxide as Y. We know that X plus Y is equal to 250 grams. That's the mass of the mixture. We also know that the moles of aluminum divided by the moles of the mixture is 67.2% or 0.672. So if we knew the mass of aluminum, we could divide by the molar mass of aluminum to get the moles of aluminum. If we knew the mass of aluminum, we could again get the moles of aluminum in the denominator and add to it the moles of manganese 4 oxide, which would be its mass, which we don't know, divided by its molar mass, which we can look up, 86.94. So now we have two equations, this one here and this one here, and two unknowns, X and Y. But we know that X, from this equation, could be calculated from 250 minus Y. So we can plug in for X 250 minus Y. We then have one equation with one unknown, and we can solve it using algebra. So that's what I'll do here. I'll distribute the 0.0371 through in the numerator and in the denominator. And in the process, collect my like terms. I'll have a y term down here, negative 0.0371, which I will then add to 0.0155y in order to get my negative 0.0256y. Now I'm going to multiply this entire denominator by both sides of the equation, and I will get this. I'll then combine my y terms by moving this one over here, making it positive, and moving the 6.23 over here, making it negative. And I will get this. I'll then divide both sides by 0.0199, and Y is 153 grams. Y was manganese 4 oxide, so that means aluminum must be 250 minus 153, or 97. Now I know the masses of the reactants, but this was only half of the problem. Now that I know the masses of each reactant, I need to figure out the mass that the mass of product that each reactant can produce to determine the limiting reactant and the theoretical yield. So if I have 97 grams of aluminum, if I divide by the molar mass of aluminum, I will get the moles of aluminum. I'll then go to my balanced chemical reaction. The product that we are interested in is manganese, and I'll convert the moles of aluminum to moles of a manganese, seeing that it's a 4:3 relationship. Then when I have moles manganese, I can multiply by the molar mass of manganese to figure out the mass of manganese that can be produced from 97 grams of aluminum, and we get 148 grams manganese. But we don't know if that's the theoretical yield until we figure out the mass of manganese that can be produced from 153 grams of manganese 4 oxide. To calculate this number, we'll take the mass manganese 4 oxide divided by its molar mass to get moles manganese 4 oxide. Then we'll convert the moles manganese 4 oxide to moles manganese, seeing that it's a 3-to-3 mole relationship. Then when we have moles manganese, we'll multiply by the molar mass of manganese to get the mass of manganese that can be produced from 153 grams of manganese 4 oxide, and it's 96.7 grams. In looking at the two of these, this one is smaller. We can't make any more than what our limiting reactant allows, so the theoretical yield is simply 96.7 grams manganese.